In this experiment, what we're going to do is now find out the other characteristics, because up until now, all we've done is find the location, right? We found the location earlier, but we need to find the size, attitude, location, and type in order to describe my image. And all we know right now is the location is the same. That's all we know, is that's the same. So we're going to do a little more sophisticated experiment to find out the other three. And this is using an arrow. It's a full-sized object. So I'm going to do the same thing, though. I'm going to put my light through one end of the arrow, and I'm going to put a few dots along my incident ray, and then do a few dots along my reflected ray. And what this will do is allow me to trace it back. I'm going to put a second one in the other direction, just like we did for our dot. And this will allow me to see its light in and out. And this is going to let me locate the one end of the arrow. Then I'm going to do the same thing, but for the other end of the arrow, for the pointy end of the arrow, because I need to find it as well. I need to locate both ends of the arrow. This will let me see the size of that arrow and also see its attitude, which direction is it facing in. That's pretty important. So here I'm tracing the light in and out. Now I end up with a much messier looking diagram, but it is pretty straightforward. It's what we did before. I have light going in and out. You can see the arrow in there, and we're going to locate it now the same way we located our dot. I'm going to now trace my lines. I'm going to trace the line going in, and then trace it coming back out. That's my first reflected ray. And then I'm going to do the same thing for my second reflected ray. Remember, it's the reflected rays we care about, because the light reflected off the mirror is what's going into our brain. And then our brain traces that reflected light back, because we think light travels in straight lines. So it helps us locate the image in the mirror. I'm doing the same thing now, but for the other end, light in and light out, my reflected ray. And I'm going to do the same thing for my last one, because remember I did two beams on each end. And this will let me locate my image. And my image is going to look just like my object, but be on the other side, inside the mirror. So now I have my four reflected rays. And I'm going to trace each of those back, because that's what my brain is doing. My brain believes light travels in straight lines, so that light that enters from the reflection, it travels backwards. Your brain does. It traces it back and finds it. So that's one end of my arrow. That's the flat end of my arrow on the one end. And then I'm going to do the same thing for my other two reflected beams. I'm going to trace them back and see where they cross, because wherever they cross, that's where my brain will locate that object, because both beams came from the same place. Technically, your brain is doing this with hundreds of light beams. I'm only drawing a couple on each end because it doesn't need to be painful. So I'm going to draw in my arrow. My arrow is pointing to the right on my diagram. It's a little small, so maybe you can't see that, but it's pointing to the right in the diagram. It's also going to be pointing to the right in my image, because you'll notice that's where the light came from. When it comes to the size, both of those are the same size. They're both the same size, and they're pointing in the same direction. So my size is the same. My attitude is upright. Remember, upright means in the same direction. We know our location already. It's the same. We found that out in our last experiment. And our type, it's inside the mirror, so it's going to be virtual. If it was real, it would be on a screen, and there's no screens involved in this. This is inside the mirror. So a plane mirror has a same size, upright, same distance, and virtual image every time.